Okay, good morning. So let's start about a little bit. You already read the agenda, I'm going over it. Let's talk about the motivation, the aims, the target. How do we got this RFID passport? How was it developed? What was the design goal? And what's the outcome and the result? And at the second part of my talk, we will have a deep technical view of what was done with all our taxpayers' money. So, any one of you knows this nice guy? His name is Mohammed Atta, famous person in the Western as well in the Eastern world. He unfortunately made two mistakes. One was crashing in the World Trade Center, and the second mistake was done by the US Passport Authority. They gave him a resident visa 12 weeks after he was detected as an attacker and terrorist. So now the government decided to make a biometric traveler identification, and there was a dream from the government how to deal with all the threats and security threats and dangerous people and dangerous travelers. So the government decided to build a multi-biometric double gate. You know why double gate? You can trap them. A double gate with lightly supervised to cut down costs and maintain non-automated entry channels. So the aim is, if the next couple of years Airbus 380 is arriving in Vienna airport and 800 passengers wants to immigrate, you can imagine how long the queue would be. So the idea from the government is, we have an automatic entry gate, so you put in your biometric passport, the system is checking your biometrics, and then the gate opens and you're allowed to get in. And the rest few passengers, they have handwritten passports, potentially from Pakistan or from Egypt, because security in this passport is not so important. All terrorists are coming from Europe with RFID passports, getting through the system automatically. And unfortunately, what's happened? The government just asked first the security print industry and the security print shops. Each European country has, for instance, a company or an agency, mostly owned by the state, who is producing our banknotes and passports. And they actually ask the banknote guys. These print shops are acting on a global basis, so they have a lot of banknote customers worldwide. They have extensive know-how in secure printing, but unfortunately they have no IT know-how. They don't know anything about cryptography, IT security, and they never done an IT project. So what happened? The print shop asked the smart card industry. And smart card industry, oh, good idea. We have huge amount of technology and see huge potentials. So we can just build something nice. No, just a biometric passport is not good enough. We need to put some value in to sell more of our products. And the result was the industry came up with an idea for the electronic passport. This passport must have a multi-purpose use. The same design for the national ID cards, but additional, it should be usable for electronic banking, for doing your e-government. You can use it for electronic signatures to encrypt your emails, for email encryption, for travel ID, and additional as electronic payment. And you can imagine how the result looks like. So, of course, we have to use heavy cryptography and PKI. We have to use biometrics, because this is the main goal of this design. It must be 100% secure against counterfeiting, and improve facilitation, like minimizing time spent on legitimate travelers, segmentation of low-high risk travelers, and minimize immigration time for travelers to give them a benefit. The next thing that's happened is an organization on the global basis, ICAO. This is the International Civil Aviation Organization from the United Nations, came up and set up the standard group. This standard group was stuffed with printing experts and some crypto guys who know something about algorithm. But no one knows anything about implementation, and this design was driven by the RFID manufacturers. No one looked at risks or design goals. You all know this goal, keep it stupid and simple. No, we have to do it complex because it's more secure. The next thing what this group hit was, oh shit, we have patterns. If you want to store your fingerprint, usually it's only one way to store your fingerprint secure. We are building a hash out of this fingerprint. This is easy for fast composition and stuff like that. But unfortunately, all these hashes are patented. So if one country, for instance, Austria or Germany or France, puts in his fingerprint hash, every other country in the world who wants to check your biometric passport has to pay license fees for this country. The next thing is, we have the same problem with our facial image. It's a picture on the passport. Why we just don't store pictures like a JPEG or JPEG 2000 or a GIF for the fingerprint? So we don't have to deal with the patterns, and if one country wants to use his own hash, he can get the raw data, generate the hash on site, and make the comparison with the local crime database. Unfortunately, we all know that compromises don't work with security. So now let's have a short look to the ePassport. By the way, I put the source for every of this image, and so most of the images are free and public domain, but some images I have to remove, I cannot put on the website. So as we cite from this nice group, we got an MRTD. MRTD is the name for your new passport. So the next time you want to immigrate and the officer asks you for your passport, you can hand over and here is my MRTD. MRTD stands for Machine Readable Travel Document, and also known as electronic passport or ePassport. It was specified by the ICAO and enrolled on a global basis. By the way, who of you guys has a passport with you with this sign on it? So if someone is interested, we can make we can make a backup after this talk or look what's possible and doing nice things. So let's have a short look for the ePassport from Germany, which I actually have with me. This is my MRTD. And you see the tag is embedded in the cover. Inside of this cover is an RFID chip embedded. It actually has 72 kilobytes of memory, a smart card controller, and also this passport chip has a dual interface. Dual interface means it has a USB port and an RFID port using ISO 14443 protocol. There's one alternative method. It's called the 2D barcode for encrypting information on a passport without using RFID technology. This is a Hong Kong passport as example. So they put this significant data as a 2D barcode just under the picture. But not enough space, and the passports are not big enough to put in 72 kilobytes, so they decided to use RFID. By the way, they invented a huge amount of new acronyms. So I try to translate these acronyms to IT speech, because printing speech has nothing to do with IT security, so we have to reinvent the wheel, we have to reinvent all acronyms. So this line, this highlighted line, by the way, can you dim the light a little bit?
There's no such thing as a little bit, it's 100.
Just switch it off. Oh. Better? So this highlighted line, it's called the MRZ, or the machine readable zone. So, and this is what you need if you want to visit the States. You only need an MRZ, you only need a machine readable passport. You don't need an RFID passport or a biometric passport. Your passport just needs to be readable by a machine reading this line. And actually, this line contains the data printed on this page in a machine-readable and machine-interpretable standard, also standardized by the ICAO. Now, we got the LDS. LDS stands for Logical Data Structure, and is something like a directory or format. All data are stored in DGs, data groups, and not in files. But a data group is something similar to a file. The first data group, for instance, is storing the MRZ information. So all information that's printed, this line, is stored as electronic file in the first file as a DG1. The next file is a DG2, and this is your picture. The picture that's printed on your passport gets stored in two possible formats. One is a standard JPEG, and the second one is a JPEG 2000. The next data groups, 3 to 9, are fingerprints, iris image, and these are optional things. Finally, we have an object. It's called security object data and cryptographic signatures. And we have something like an index or directory. So with this file, EFCOM is a list of the existing data groups, something like a directory index. All data is stored in BER encoded data, like ASN1, but it is not ASN1. This is important to know. All the biometric groups, starting from DG2 up to DG9, it's not form, are using CBEFF. This is a common biometric file format, and this is actually a meta format telling you once more, this is a fingerprint with a specific data. So for instance, you have a file that's saying at this place this file must be a picture, and then you put in a meter format and put in this meter format the JPEG 2000 or JPEG and telling you, oh, by the way, this is a picture. So just to be double clear. There are some security features. For instance, the first versions of this passport has a fixed unique ID. So unique ID is something like a MAC address or something like a device ID. You need to make anti-collision and to communicate with the RFID reader. So at the first passport, you don't need to read the passport. Each one got a unique ID with activation, so you can just track someone else by passing it over a reader, and that's it. And they thought, no, that's not a good idea. They came up a group, they presented a smart bomb, gets activated by a unique ID from an electronic passport. They thought, no, we have to do something against this. This is too obvious to crash and to be dangerous. And after a demonstration showing that in the Middle East, Americans get killed specifically by bombs activated by biometric passports from the States, they thought, no, we have to change something about this. The result was now the actual RFID chips and transponders have a unique serial number, and this serial number gets randomly activated. So for each one, it's something like for each IP packet or for each ARP request, your machine is sending a new unique MAC address. So you are no longer trackable by this machine address. You are trackable and traceable by 100 more things, but this is the first thing that I've stopped. So it prevents tracking without access control. Unfortunately, the ICAO didn't point out that the MRTD requires a unique serial number. So, for instance, some countries like Netherlands and the early Belgium passports don't have a unique ID. So they are easy to track. Next, they invented a method, it's called passive authentication. This method is mandatory for all passports. And this method is for proving that the passport files are signed by the issuing country. So the inspection system has to verify with some sort of technology if the data in your passport is your real data and the data is signed. So the EFSOD contains the individual signature for each data group. The EFSOD is signed by itself, and the document signer public key from a public key directory is one part is stored on the passport, and it's signed with a private key, and the public key is available through a public CA. So, useful if the country root key is public known. Unfortunately, they never thought out that there will be one huge PKA directory, so every country issuing RFID passports operates his own PKI. One diagram showing you how this hashing works. So they are hashing the files or the data groups, and each hash got a hash over this data. So they are generating some sort of master hash, and this master hash is signed by the country CA. Yep. So the next question, you think it's a good idea to hide your passwords like this? That's exactly what they are doing with basic access control. So to prevent reading from your RFID chip, they invented a method, it's called basic access control. And access got granted after data in inspection system are authorized, and authorization is going through this MRZ. So actually they're using the second line of the MRZ and generating a triple desk key from a static secret that's printed on the passport. What does it mean? Is it really secret? Your data? Unfortunately, the access key is printed on the passport, and many times your passport is put on Xerox machines, like in hotels, if you rent skis, or if you rent a car, or rent a cell phone. They always make copies of your passport and store it in some database. They are stored additional in many private databases, like airlines, like banks. I have seen implementation where the check-in counter was directly at the airport door, and the check-in process was done via unencrypted wireless LAN, and all MRZ data got pushed to the check-in system via wireless LAN. This means all the access keys for the passport got pushed over an unencrypted channel, and everyone can read it. So to access your passport or to track you, you cannot do it with a unique ID, but you can do it with a handshake, and even with a half-open handshake. So if the basic access control handshake data is known, the random ID is totally worthless. It's something like, you don't know the MAC address of a machine, but you know his IP address. So you can still access doing this IP address. And you can access to the data, like the DG1 and DG2. And additionally, you can access to the security object. And what does it mean if you can read something? Of course, you can clone it. Because as soon as you have the structures, if you have the data, you can put them into a new blank tag, and that's exactly what we have done 1 year ago. Then they came up, oh, we know this is basic access control and cloning passport is a serious risk. Oh, by the way, we have to cross it out. It was by the German government a new redirection of the study from the BSI. So now we came up with a total new thing. It's called extended access control. Because the basic access control is not safe enough to put the fingerprints from our citizens inside. But with extended access control, we are 100% secure. So the extended access control should prevent the unauthorized access to biometric data. Unfortunately, it's not internationally standardized. Every country is generating his own algorithm, his own method, and they have to be shared with the country where they want to share the fingerprints. And access is only possible with a certificate from the issuing country. So I want to read the fingerprints from this passport. I'm not allowed, so the passport reader has to call home to Germany, and Germany has to give you a certificate, and with certificate you can read this fingerprint. Just imagine you are a train conductor and have to check certificates or train tickets or something like this, and the ticket is valid for 15 seconds at a specific date, at a specific time, and you, as conductor, don't have a clock. You don't know what time it is. You never know where are you. You don't know what time it is. You don't know is it correct and is the time is correct. So unfortunately, they just forget that this electronic passport don't have a reliable and secure time source. So how good is a time-restricted certificate if the inspection system or if the RFID chip and the passport cannot verify it? So this means once this inspection or this extended access control certificates are called CV certificates, and once the CV certificate is captured, all MRTBs have been read using a CV certificate issued earlier could be accessed. Now, the biometric data, don't forget it is a GIF image from your fingerprint, not a hash, can be accessed as well. And the MRTD cannot verify the validity of the timestamp on a CV certificate. Even then they came up with a new method. Okay, we don't have a clock, but we know the timestamp from the earlier access certificate, so we are just going to store the certificate inside your passport. So they make it worse. Now they're going to write the last access certificate and the timestamp from the certificate into your passport and blocking access to earlier issued certificates. So what's happened if I'm going to spoof a certificate with a timestamp in 2090? Now I can deactivate the MRTD. And I can write now to the passport. So with extended access control, we got even new risks. False CV certificates with false timestamps can now deactivate the MRTD permanently. This can be done by fraud or error. A root regime could misuse this CV certificate to obtain fingerprints from the passport holder. And no one is guarantee you that a friendly regime we are going to share our biometric data got changed for the next 100 years. So they can store the CV certificates and can access your fingerprint. And with this fingerprints, it is possible to produce false evidence. Anyone knows the method of cloning fingerprints from the CCC? So what they're doing actually, they are printing your fingerprints with a laser printer, putting it on a teaser strip, and you can just confuse the inspection system. The next problem is it's not possible to revoke certificates from the MRTD, because once the certificate is inside the passport, it will be there for 12 years in Europe. So for 12 years you cannot change the certificate. There's no way. It's just burned in. One idea was, if we got a crypto problem in 12 years, so why we just don't cut down the lifetime of a passport to 6 years or to 4 years. So you have to get a new passport every 4 years. Because this is the only way to upgrade the security, to put in new chips. So I got millions of questions. Why in the hell did we clone passports? It's quite easy. A normal tag is read-only. The normal passports are read-only. But the data could be retrieved from an issued passport. So it's something like a 7-step thing. So you can retrieve the data from an issued passport. Now you use a micro-oven trick to kill your original from the state ship. Use a clone tag and extend this with an exploit. So right now you have really funny passport. You can attack the inspection system or the backend database or things like this. And we've done some proof of concept things. So, by the way, inspection systems are not evaluated right now. They claim the RFID chip is highly evaluated and highly secure. But this is not the secret, this is not the vulnerable part. The vulnerable part is the inspection system that let you into the country. And the problem is off-the-shelf PCs are often too complex to be formally validated for correctness. The next problem was the MRTDs using JPEG 2000. And everyone knows JPEG 2000 is really complicated. So it's easy to exploit. You know, you can use Metasploit, there are some CVE example exploits. You can just extend your passport with some interesting data. Let's have a look to the vendor's design of an inspection system. So they use an off-the-shelf system and it's designed for Windows XP. No security improvement in the software. What's happened if you ask an inspection officer or border control, do you mind to plug in this USB stick in your machine before you're controlling my passport and then let me in? And that's exactly what you're doing. You can just transfer data from your passport into the system from the police or from the border control and executing things. Yeah, extended security by traveler. And now let's have a look why it is possible to do such interesting things with this passport. Now this is a deep technical view to the LDS. You know what LDS stands for? As I explained, logical data structure. This is the data structure on the ship. And what do you have a pointer or something like this? Hey, share. Don't speak. Do you have a pointer, laser pointer?
No, we don't.
Oh, okay, thank you. So actually we have here right now a three view of the logical data structure. So we got here, after we got the connection, some of you guys know the smart industry, it's called answer to the Z. So we got the answer to the Z string, and then the view of the LDS structure. And this is how the LDS structure must be passed. We have the EFCOM, we have the EFSOT, and the data groups here. And now I'm going to open the structure a little bit. You see now we have the EFCOM, the EFSOT, and all the data, and we can now focus on the security object. This is the structure from the security object, and you have to puzzle together all these parts only to see for the signing authority. This is a de.bund.bsi.string07 signature. So to get the payload out of the passport, you have to pass and decode the whole structure. And after you have passed, decoded, and computed the whole structure, then you can generate the hash and verify the hashes. And right now, this is the next parsing area, and so on. And this is the octet string of the hash signature. Right down at the leaf of a huge tree. And as a result, we got a nice problem. The problem is, first you have to read the ship, then you have to decode the LDS. You have seen the data, how complicated this is. And after you have decoded and passed all the things, you can verify the document cryptographically. The problem is, first pass, then verify, so first compute and then check if the result is correct. It's something like you go to an ATM machine, put in your card, getting the money, and after you got the money from the ATM machine, you can punch in your 4 digits code to check if you are legitimate to get the money. And if not, something happens. And this is actually the design how the electronic passport works internally. Cool IT concept, isn't it? First, read, then access, then allow, then compute, and then verify. So, one of the problems is biometric data should be reduced to hashes only. Fingerprints are just stored as pictures. So reverse engineering of fingerprints is possible. And this passport is just against any bad practice of IT security. The next thing is, they want to make something like ASN1, but they don't understand how ASN1 works. So they use TLV. For example, anyone knows in the room how ASN1 works? Anyone knows how a compiler works? So you give a lex and you get code and you put data in, and the ASN1 system generates you a parser, an encoder, and a decoder. So you put just your data in, and the encoder generates ASN1 code, and the decoder can decode it and you get the perfect parser out of it. Unfortunately, they have done it by hand. And just the TLV data. It's something like, oh, we're generating an IP stack, but we don't use libraries and parser and a generator. We are writing our code by hand because we don't understand what a parser is. The next thing is we have redundant meta format for biometric data. The next thing, I really like it, if the signing key is lost, the whole country is doomed. Anyone can sign and generate passports. The idea, first the data must be passed, then it could be verified, it's a huge new concept for IT security. And the problem is the design was made by politicians and not by IT security experts, so it's easy to manipulate data. I put in some snake oil warnings. I gave this similar talk on an ICAO conference. Oh, we got nice comments. So the first one is, trust us. We are the experts, we know what we are doing. The next thing, after we came out with this clone passport, this was only possible. The standard was accessible from the ICAO website. But we removed it, now we are safe. Security by obscurity. I did the primary purpose of the passport, I read it. There's no security risk at all. And the next thing is really nice. The RFID chip will be protected by the security features of the printed paper in the passport. Because we have a 100% not counterfeitable passport, the chip is quietly unsecure, and we put in the chip, and the chip got protected by the security features in the printed paper. It's something like your Microsoft license on your PC got protected and secured by the license certificate. Because it's not possible to clone or to manipulate the software, this license certificate is protecting your PC, and as well against viruses as well. And the next certificate I really like. So I gave this talk in London at the Secure Document ID World, where the technical director from the electronic passport group from ICAO was there. And this is a statement from this guy. It's right that these security flaws could harm an IT system, but we have to keep in mind that the electronic passport is a security document and has nothing to do with IT systems. Come on. Something like, no, we have here something different. We only use IT, but it has nothing to do with IT. This is a medical problem, but we use computers. This is a security problem, but we use paper. The director of the electronic passport group from the ICAO.
Well, let's quote him in every signature that we have, huh?
Yeah. Oh, he already knows it. And actually he got bashed by his engineers after his statement on the conference.
All right.
I have issues. Change the name to I have set. Intelligence is so.
So I have two options right now. So I can give you a short presentation what we have done, and then we can start with the question and answer round, or we can start with the question and answer round right now, and then I can give a presentation, and anyone who wants to get hot food for lunch can get out, and the interested guys can look at the presentation. Yeah?
Just a few about this, the double variable you were mentioning at first, because I read that story about FX. What troubled this picture is electronic passport. And so basically what they did is they changed the size of the picture. So
oh, enrollment. That's a whole another story. Now, if you want to have an electronic passport, you have to enroll. So you have to come to your local authority or to your citizen office or stuff like that and bring them your picture, take your fingerprints, and have to do this enrollment. But unfortunately, the citizens' offices in Germany has all internet access from every machine because the unemployment insurance requires to use the internet system. And they don't want to have 4 or 5 computers on their desk. So they have an internet system, a cryptographic system, not protected, and no one is checking in its enrollment if this is your real picture. They are just signing it. So you can bring a picture of your twin brother or someone else, or you can Photoshop this picture to fit it into a mask, because they're not verifying after rolling out this passport or giving it with a biometric image scanner, that's you. Yeah?
Of course, just before you give them your picture, you
Sorry?
your USB
Then wait a
stick behind the computer.
No, you don't need to stick in your USB stick, because they're using unencrypted machines. You can read all the content on their screens from the window, if they're flat screens pointing to the window. Sometimes you can see from the parking ground, from outside, what's going on inside. And you know, these are stupid bureaucrats. They have no clue about IT security. And the whole enrollment process predicts on these local offices. And on the other thing, they don't trust the embassies anymore. So you have to, every time you lost your passport abroad, you have to travel to Germany with a special permission and get a new passport in Germany. So let's see if we are able to bring a demo up right now. So I do have a reader here. Let's see if it's running. It's a little bit complicated because this is all okay. It works.
Because have you ever killed a passport? Did you do research?
No, I make security copies of it. I just worked on copies. Yes?
Because I want to remind you, just if there's no, if the audience is asking a question and it's not on the microphone, please.
I'm going to repeat it. So the question was, did I ever kill a passport or destroyed one? And I always made backups and work on security copies on the passport. So I just don't want to get into trouble. And by the way, there's one thing that I really recommend anyone who's working on this. This is these nice envelopes. They are pretty good working, and they are shielding the RFID frequencies from your passport. A little bit unhandy if you want to check in. You have to put it out and put it back again, and you go to the border security and put it out and put it back again and stuff like that. You got a special inspection. Something like a terrorist or something like this. So you got a special queue and we take care of you. So this is a generic smart card shell. It works as an interface. Yes. So it works as an interface between the PCSC driver and the electronic passport, and you can script things, and make automation. So, for instance, for my colleague, I have his passport here, and I just make a copy of it. You can see. This is a biometric data, and now we have here his MRZ data. This is exactly what's printed on the passport. And if someone is interested to get a security copy of his passport, just go ahead. The nice thing is you can use this JPEG and put in some random data or some buffer overruns and stuff like that. And I made a test on the CeBIT. It's a security hall. They have some passport reading systems and presenting them all running on Windows. And I just put in some typical data structures for the JPEG 2000 exploit and was able to crash at least 4 of these machines. But unfortunately, no one lent me this machine for a weekend to get a working exploit out of it to have some more fun. And the next thing is, how could you expect that in every border control point you are putting in something like a patch and update and maintain and thing, and you have to audit all the things. By the way, all the operators have no clue how IT systems work at all. And now we can use a structure. This is an, yes?
Is it illegal to modify this data?
No, it's not possible, so it's not illegal. This is a statement I got from the German Department of Justice. They are 100% safe, it's not possible, so it can be illegal because it's not possible. Yes? No. Michael, yeah?
Hey. But if they have extended access control turned on, that would certainly make it a lot harder to put in your JPEG with the buffer overflow.
No, you just need to capture one of the CV certificates. And after you got the CV certificate, it's all bogus. So, and now with this Explorer, you can go through the data structures of the passport. And for instance, we have here in the EFCOM illegal beer encoding. So they actually put in, it looks like ASN1, but this encoding is illegal. So we just guessed some numbers and some text. It's something like, I want to design a protocol. Okay, I use this tag is indicated by this value, this tag is indicated by this value. Guys, there are standards outside. Why should we listen to it? We can make it more secure if we reinvent the wheel. So they reinvent the encoding, they reinvent all acronyms, they reinvent almost everything. But still use ASCII. That's good. Let's see if I have one of this BSI Golden Reader tools with me. So you can see some information. Nope. So I just don't want to get caught at the border with a Golden Reader tool coming from the States with a tool to verify passports. Okay, any more questions?
Any questions like, how do I random generate my picture on my passport?
How much hardware do you need to...
Wait.
The question was, how much hardware do I need to make a copy of it? It's not a matter of hardware, it's more a matter of software and time and getting through this whole damn ICAO standards. You know, standards are not user-friendly written normally. And the result was you need one RFID reader. You can buy it off the shelf. This is a special reader. It has a SIM card embedded with active identification. By the way, if you want to have a reader with a SIM card with active identification, you only need the product number and you can just order it. If you have a corporation or something like this. Why do you need this reader with a SIM card? Oh, we have a project with the government of yalla doing identification and passport verification boxes. You sign a nice letter in Arabic and you get this reader.
How much does it cost?
$200. Yes?
Stop. Audio.
For manipulating the picture on the passport, you'll need to capture a certificate.
No.
No? So
if you manipulate a picture on the passport, of course the MD5 hash will no longer be valid. But the idea is manipulate a picture, put in an exploit, and now bypass all cryptographic methods.
So the exploit will only work if the signature is not verified. Because if somebody verifies the signature, it will detect, okay, that's a broken signature. I want decode the JPEG 2000 image because the signatures?
No. The structure is you have to read all documents on the passport. You have to run your parsing tree, and after everything is parsed and puzzled together, you run the MD5 hashes or the SH1. You run the hashes over the data groups, and you run a hash over the hashes and compare it with a signed hash. So you have to compare the signature with a public key from the issuing state, and then you can see if the hash is manipulated. But this is the end of the stage. So you have many times at this parsing tree to manipulate the inspection software and just jump out of the verification routine. So for instance, you have a function open the gate and let me into the country, or verify and then open the gate. And you just jump, it's like on the C64, just insert a go to 20 and just skip the validation. Yes?
What about resigning?
Can I remind you, please, to think about the people who want to listen to the recording?
What about resigning the picture with new fake certificate? Because I've heard that the PKI for the passport certificate verification was not really implemented.
So what they're doing is they're putting in the public root certificate in every reader. So every reader has a hard-coded root certificate.
For every country?
Yes.
Okay, thank you.
So like officially now we have the lunch break, but it's the break. We can still have some more minutes for questions if you like. So
I can make some. By the way, I don't make fun about disableds. I make fun about data collectors here with this picture.
Yes, we are politically correct in some things.
No, I'm allowed. As soon as he is a minister, I'm allowed to do it. If he is a private person, I will never do this.
Fair enough.
Okay, thank you.
Well, thank you then.